All right. So we're going to talk about, we did a review already, which I think was plenty sufficient. If you guys are still having issues, come to me after class and I can give you guys some more practice you can do. Otherwise, we're going to start talking about things called branching statements, logical operators, and while loops. So up to this point, all the programs that we've been writing have been linear. They've been top to bottom. They run one line at a time, and then they finish, right? And this is fine for like practicing and learning how programming works. However, a game at its core needs a lot more than just that to run. Think about it. When you run a game, it doesn't just run once, one time, and then exits automatically. It stays there, and you interact with it over and over again. You could be playing a game for as long as you have that program open. So you need a way to basically repeat some behavior. Okay? And oftentimes, too, games give you choice. Like, for instance, a lot of games, the first thing you do is like pick like your class or your hero. So immediately, your options that you are presented with change. For instance, in World of Warcraft, as soon as you pick your race, certain classes are locked for you. Now, this means that you can branch how your program runs. You can change how your program runs based on either input from the player or the results of something else that happened earlier in the game. So you will often have to write programs that will skip certain sections of code that you write based on some kind of condition that you have. Okay, so let's talk a little bit about what it means. We did a review. We're going to go over that. So I want to talk a little bit about C++ and how it uses conditions to change how a program runs. So last week we talked about variable types, right? I showed you guys integers and doubles, and I showed you guys a type of variable called a bool. Now, bool was a very simple type. It literally only can store either true or false, which internally is stored as either 0 or 1 or 0. And in this case, you can use that knowledge to understand that that's actually how a program determines whether something is true or false. And anything that you write actually in C++ can be evaluated as true or false as well, which is interesting. So here's what I mean. Like anything that is an arithmetic operation can actually be considered true or false. And the reason why that works is because C++ actually considers 0 to be false and any other number to be true. Okay? So if I asked you whether 2 plus 2 is true or false, C++ will tell you that that's true. Okay? So what that means is that any value greater than anything that's not 0 will be evaluated as true. So in addition, this means that you can also use this concept with these new operators, which I'm going to show you, which allow you to compare expressions on one side to the other. So here are some expressions. These are called relational operators that allow you to compare an expression on the left side to an expression on the right side. So let's start with the top here. And these operators are the C++ relational operators that you can use to compare one side to another. This is comparing, oftentimes, numbers from one side to another. The first relational operator is the double equals operator. Now, all of these operators, when you use them, will tell C++ whether that expression is true or false. It will say whether the result is true or false. That is what you get. Whenever you use one of these, you'll either get a true result or a false result. That's it. That's all you get, true or false, okay? So the first operator is the equal to operator. It asks, is the thing on the left equal to the thing on the right? Okay? Pretty straightforward. So the first answer here is 5 equal to 5. And remember, it's going to either return true or false. So the first case here, 5 equal to 5. Is it equal to 5? And the answer is going to be true, right? 5 is equal to 5. So the result here is going to be true. Is 5 equal to 8? The result there is going to be false. That is not true. Now, conversely, the second operator here is the not equal to. That is an exclamation point with the equal sign. And that will return true if the number on the left is not equal to the number on the right. So what does this return here? True. What does this return here? False. Okay? Greater than, less than. these also will return true or false based on what's on the left and the right. If you guys remember, I remember like it was taught to me as like an alligator eating a small number, eating the bigger number. I think that's how it was. But in this case here, it's asking, is the number on the left greater than the number on the right? Okay? So this one will be true. You flip those two numbers, now it turns into false. And it goes down the line. These last two are pretty similar. However, they're still useful in their own right. It's basically a greater than comparison, but it also will return true if those two numbers are equal to one another. Okay? So here, this will be true. Here, this will be false. This will be true. The second one will be false. Okay, so you can use this to your advantage because true or false results will often be used in if statements. So if statements are supremely important in programming. It'd be very hard to write a game without having some kind of if statement. And this is the format, the syntax for how you write an if statement in C++. You write the word if. Inside a set of parentheses, you have some expression, okay, that evaluates to true or false, followed by a statement of code. If the expression is true, that statement of code is executed. Okay? It means it'll run that code that's in that statement. If expression is false, it actually will not run the statement. It skips over it, and it goes to the next line of code that comes after that if statement. Keep in mind that statement here is anything that is considered a valid statement in C++, including, you can put curly braces there too. Okay, let's talk about what this looks like in code. So I'm going to write an if statement, a very simple if statement, like so. This is going to be my expression here. And then I'm going to write that. So remember, back to the PowerPoint, I write my if statement. In parentheses, I put my expression. Then I put my statement followed by a semicolon here. Okay? So if this is true, it'll run this statement here. Okay? Vice versa, I put the word false in here. Those are my first two if statements. Let me show you what happens when I run this code. So here's my program. So this yellow arrow here on the left, which is this is the debugger, will indicate the next line of code that's about to run. So the first thing it's going to do is going to look at this if statement and say, hey, is this expression true or false? If it's true, go ahead and run the statement that's for this if statement. So I'm going to hit continue. So this statement is true, which means it'll run this line of code. So if I go to my console, you can see it wrote out that statement. Now, line 13 here belongs to this if statement, which means that this thing will be false. So watch what happens to the yellow arrow here. It skips all the way down to 16. It's the next thing that no one wants to run. And look at the console, nothing print out there. Okay? Does this make sense, how if statements work? Okay, let's do a little bit more. So I'm going to create a variable here called score equal to 1,000. And then now, I'm just going to put that in the if statement here. Will this if statement run or not? It will run. Notice I put curly braces here too. Keep in mind that these curly braces make sure that everything that is inside the curly braces is treated as one statement, okay? This thing here, imagine it looks like this, okay? The reason why you use curly braces is if you ever want to write more than one line of code for an if statement. And just while you're in this class, I want every single if statement to have curly braces for the statement that follows it, okay? So this if statement will be true because, remember what I said, any expression can be evaluated as true or false, which means score is equal to 1,000. It is a non-zero number, which means it'll be true in this case. So you'll see this value here. Any questions on that?
But if you set the initial initialization to 0, then it wouldn't print, right?
Correct. If you set this thing to 0, this would be false. Any non-zero number is true, and 0 itself is false. All right, let's do one more, or a couple more. Now let's use our relational operator. Okay, so here's me using an expression. I am comparing the number on the left to the number on the right. If the number on the left is greater than or equal to 250, I'll run that line of code on number 25. Okay? So if you can see, a score is going to be equal to 1,000, so that statement is going to evaluate to true, which means it's going to print out that line. Okay? Questions on that? Does that make sense, anyone? Everyone? Okay. Now, if statements are interesting because it's a statement that you can run, which means it runs everything inside of the curly braces. So if I write another one, let's say greater than or equal to 500, same exact comparison, except now I'm comparing against 500. But look at this. I'm going to write another line of code in here. And you know what you can do? You can write another if statement in here. What does this mean?
It'll mean you'll be flipping scored 500 or more, and
then it runs this.
it'll print both times if your score is at least over 1,001.
It's over 1,000. So watch my expression though. Like this statement here, this whole thing that I've set up, I set up an if statement inside of another if statement. Watch, I'm going to collapse the code to make it look like one line. So I have two lines of code, essentially, here and here. And they all belong to this one if statement here, which means that these two lines of code only get run if this is true.
So if score is less than 500, you wouldn't even run the second if.
That's correct. If score is less than 500, I don't even run these two lines of code. I'm going to minimize this to look like one line of code as well. So this is an if statement, and the expression that's used after it is inside my curly braces here, which consists of these two lines of code, and the second line of code happens to be another if statement. And you can do this over and over again. This is what's called a nested if statement. You have an if statement nested inside of another if statement. And you can do this almost as much as you want. You can nest if statements. Now I'm just going to go ahead and say that typically if you have more than 7 nested versions of this, it starts getting, you should really reconsider how you're writing it, because oftentimes that means you're doing it wrong, because there's usually a better way to solve that problem. But if you nest it, notice that this if statement looks like it's indented compared to this one here. So you know that this one belongs to this if statement here. All right, questions on that? All right, let's do the next one. So here's a continuation of it. because oftentimes you want to do something when it's not true, just as often as you want to do something when the expression is true. So this is what is called the if-else clause. So we have our expression, our if statement, that has an expression inside parentheses with a statement that follows it. But immediately after that statement, there's the word else followed by another statement. The way this works is that it first looks, hey, is that expression true? If it is, it runs statement 1 and skips over statement 2. It doesn't run statement 2. Read it like you would English sentence. If this is true, do this. Else, do this. Means do one or the other. Which means that if this expression is false, it skips over statement 1 and goes immediately to statement 2. Let's see this in practice. Enter a score. I'm going to write a statement that says if the score is greater than or equal to 1,000, let's just do 9,000.
I see it.
Okay. Else so look at this expression here. If this is true, we run this line of code, and we will not run this line of code. So let's run this. So let's type in a power level here. Let's type in power level of 12,000. So for 9,000. Okay? And I'm gonna. That's it. That's the program. It ends right here. If I enter power level here, see how it rolled out less than 9,001. So this is basically a way to run code anytime this expression is false. Now, this is actually a really key thing to use in games. So if statements by the whole are supremely useful. Like there's like all kinds of things that we use if statements for. For instance, things like, hey, if someone is under my reticle in Overwatch and I'm playing Zenyatta, I'm going to show a little cursor on screen and I can hit a button to debuff them. Or if someone takes damage and their health goes below 0, print out, tell them that they're dead, right? Or if you ran out of time in the game, end the game and tell them the game is over. Now, the else clause goes with a lot of those. For instance, if this if statement is something like this, where instead of score, I'm going to say enter time remaining in the match, and I create this thing to be a double. Time is less than or equal to 0. Like that. Otherwise, you can just print out the time. So imagine that time here represents like time remaining in a game of Overwatch, right? And you enter like 10 seconds left. So you look at this if statement. This if statement will be valid and say, hey, is time less than or equal to 0? No, the game is not over. Anytime you still have time on the clock, you print out this. Right? Doesn't matter what the time is, you just say, hey, you have greater than 0. When you write an if-else statement like this, oftentimes you have one very specific condition you care about. Like this, I care when the time hits 0 to end the game. And then otherwise, I kind of don't really care. I kind of just want to let it go and just have it do whatever, which is why in this case, I don't really need to end the game or anything. I just say, hey, this is how much time is remaining. Okay. Questions?
Is that kind of how you guys do like overtime and stuff? When,
Mhm.
like they're still alive?
Yep.
That enemy team's still alive?
Yep, there's an if statement inside our code that says, hey, we have two specifically. One, is the time 0? Like this. Otherwise, just let the game run. Because you still have plenty of time, just let the game run. If the time is less than or equal to 0, the next thing we do is check, hey, are you in overtime? Because the way it works in Overwatch is you run out of time, time gets pegged to 0. When you're in overtime, time actually is just 0. We enter another condition that says, hey, we have a second time, that's how much overtime is remaining. And that starts at like 5 seconds. And then when that hits 0, that's when we end the match. So the way it would actually look in Overwatch, and this is just this is just paraphrasing here.
I've seen it hit double overtime.
Yeah, you can do this. I'll write a nested if statement here. Like so. This is how I'd use a nested if statement. See how I'm nesting an if-else inside the if statement for the first one? So let's go through this logically and just explain. If the time is less than 0, I need to run this block of code. Let's just assume time is like 10 seconds. None of this runs, right? It just says the game is still running. Let's say time hits 0 immediately, okay? Now, the second thing I'm going to do is check to see how much overtime I have remaining. If I still have any overtime remaining at all, I run this line of code, the else statement, right? As soon as time and overtime are both 0, that's when the game is over, okay? Both of those expressions have to be true in order for it to say the game is over, all right?
So how often does the computer like check?
That's a great question because this, you would have to check it a lot because time changes a lot. So the way that you determine how fast it does is how fast your computer runs. So the way Overwatch actually technically does it is we run what's called a fixed update, but we'll do it 60 times a second on the server.
Okay.
So we take the server at a specific rate. In the case of like, this basically, you can think of how many times, 60 times in 1 second, basically. It's every 16 milliseconds, we do this check. So we check if the time is run out 60 times every second. So like, sometimes in some games, you'll run it more often, you'll check more often than not. For instance, if we wrote this loop right now, if I were to make a game, like a 2D Overwatch game or something like that, it might run at like 500 FPS, right? You know when you see FPS in games, that's how many times this check would happen. So if you're running a game at like 60 FPS, you're running it 60 times a second. If you're running a game at like 15 FPS, you're only checking this 15 times a second. Okay? You're basically doing this every frame. The game is running.
Is there like a best practice, like you're using time is less than or equal to 0? Would you write it the other way? Is that if time is greater than?
You could. So this is that's a coding standard thing. I could flip this whole thing around. I could rewrite this to change it so that time is greater than 0. And it'll look something like this. I would move this into here. Move that down here, right? I could also flip this. All I did was move stuff around. It's exactly the same code. See how I flipped the less than or equal to into a greater than? Notice I didn't do greater than or equal to. That would be bad. This is an important thing to make a distinction. I'm not comparing time greater than or equal to 0. Otherwise, I would hit 0 time and it would still think that there's a game remaining. Now, the reason why I pick one over the other is really about complexity. like when you're reading code, typically you're reading from top to bottom, and you're kind of reading like, oh, what is the first thing this thing does? And the way that I've kind of learned it and the way that I approach things is I tend to put the simplest thing first. I tend to put the thing that is the easiest to read first. So I can say like, oh, what's going to happen first? Oh, time, if time is greater than 0, what's the more important thing to put first? And so in this case, I want to see that there's still time remaining. And it's really kind of a taste thing. It's kind of like if you ever write like an essay or something like that, like which paragraph or which topic you put first, it's at that level of subjectiveness. Like you kind of pick and choose what you want, but you have to keep in mind that where you put it changes how you actually write this behavior.
So there's no like best practice.
Some books will say that like you should put the smallest statement first so you can read that, because sometimes if you have a really complex statement like this, like if I undo all this, sometimes you might not even realize there's an else case at the bottom. So if you're reading code like this, when you read that, you might not even realize that there's an else statement. So some books will say, hey, try not to do it this way, because if the person doesn't scroll down, he might miss that there's something at the bottom here. So that's why you put something that's easy to read up first, so that if you are scrolling, like watch if I put this back to the way it was. So look at this. It's a lot harder for me to see this if statement and not realize that there's an else condition to it. Okay. Okay, any other questions on it? If else. All right. There's one more. And perhaps this is the last of the if else. Aha. More. So sometimes you have multiple different expressions that you want to look at. And you only ever want one of those statements to run. In that case, use the sequence of else and if statements together. This is all if, else, if. So here's how this works. The first thing you do is look at that first expression 1. If it's true, you run statement 1, and that's it. You bail out after that, and you're done with all the rest of the code in this if-else statement. Okay? If expression 1 is false, you drop down to the very next expression, and you see if that is true. If that is true, you run statement 2, and then you bail out. You continue down the line, every expression in order from top to bottom, all the way down to the very last else if. And if this statement is true, you'll run that last statement. Otherwise, if none of the expressions, none of the ones above this else are true, you'll finally run this. You're guaranteed to run at least one of these statements, and only one of these statements. However, if none of these expressions end up evaluating to true, that else is the very last one that will run. It's basically like a final statement that you run. Okay? Questions? Okay, let's write this. Okay? If score is greater than or equal to 1,000, then I'm going to write an else if I'm going to write another else if and then finally I'm going to end it with an else. So let's look at this in its entirety. So here, it starts off with score, checking to see if it's greater than or equal to 1,000. If it's true, it'll print that line 15 and nothing else, and then exit the program. It'll continue down that line, figuring out how much score you put in. So if I run this, and I type in something like 320, it says you scored 250 or more, which is this one right here. It skipped over the first two statements. This is useful in cases where you're trying to figure out, like, for instance, what tier you're in, right? Like in a game. Like, let's say you're in like bronze, silver, gold, platinum. How many stars did you get for a level, right? Like, how well did you do if you ever played like Angry Birds, or like really any game that has like stars cut the rope. Or I'm trying to think of other examples of games that have like ratings at the end. Like you get like F through A. You guys ever seen like Devil May Cry or like
Candy Crush.
Candy Crush, sure. Or like Sonic. Dark Souls? No. Dark Souls doesn't really have any kind of rating. It just kicks your ass. Devil May Cry. Bayonetta is another one. I like Bayonetta. So the way that you typically set this up is you try to figure out where they fit, right? And you can think of this as a way to scale down to figure out what range they're in. So in this case, no matter if he entered 320 or 499, I would still get this result. And how many steps you have is kind of based on the game that you're writing, right? Like if you have a game like Devil May Cry or any of the other like action-adventure games, you usually get like a rating like F through S for how well you did, based on kind of like the score that you got. Or like, I don't know, like Luigi's Mansion or something like that too. Or Pac-Man. Same thing. And that's where the if-else if statements come in handy. Okay. Questions on that? No questions on if-else if? Any other questions? Okay. So this is kind of a weird one. However, it's the same concept behind an if-else if. Exactly what we just talked about, where you have multiple expressions evaluating to statements. In this case here, we have what's called a switch statement. It's a way to give you a kind of like a condensed version of an if-else if. It's a way to write an if-else if statement just a little bit faster. This is basically a different way to write the same exact behavior for an if-else if. Just think of it that way. A switch statement is just another tool that you can use. It's kind of like a way to present a set of choices in a condensed format. Now, there's a few things that you can do inside a switch statement that you can't really do inside of an if statement. However, the most I kind of want to say is that think of a switch statement here like an if-else statement. So the way it's structured is you have a switch keyword, and then inside parentheses, you're going to put a variable name. Okay? A variable choice is going to be something like a number in most cases. Followed by that is going to be a set of curly braces. You can see at the top and bottom there's a set of curly braces. And then you see a bunch of these case values followed by statements. All this means is that case is a keyword, while value 1, 2, 3, all the way down to n are explicit numbers that you're comparing it against. And then if that number is equal to the choice, you run the statement. Followed by a break. Now, a break here means exit out of the switch statement and continue running the rest of the code. I kind of want to present a very simple example of this, because I think it's easier to explain by showing. Let's make a starter Pokemon chooser. I'm going to say I'm going to say 0 is equal to, let's do the classic. I don't know the starters for Sun and Moon. That's coming out soon, right? Bulbasaur. No. That would be a little overpowered if you could get Charizard right away. And let's just put in Pikachu. And then we'll do a standard CN into the starter Pokemon choice. This is a perfect example of where to use a switch statement because you have a single number that you're comparing against a lot of different numbers to print out what you want. So here's our switch. Inside parentheses, we put our value that we're comparing against, followed by a set of curly braces here. Okay, that's our switch statement. The first thing is you're going to say, hey, if the case is equal to, let's just do 1, 2, 3. I don't know why I picked 0, 3, and 4. If it's 1, I'm going to print out you picked Bulbasaur. And then I'm going to put the word break. Break here tells me to run this line of code afterwards. It tells me to skip out of this switch statement and go next. I'm going to continue to write more case statements here. 2, 3, and 4 to match Charmander, Squirtle, and Pikachu. So I'm going to run this once just to show you what the result looks like. Okay, I'm going to pick Squirtle. Hey, it told me that I picked Squirtle. I just typed in a number and it knew which one to do. Once again, I'll pick Pikachu. Cool. Here's how the switch statement works. I'm going to show you what the code does after you put in a number. I'm going to put in Charmander. Watch where the yellow arrow goes. So currently, the number I typed in is 2 here. That's what's stored in the variable. Watch where the yellow arrow goes down to here. It immediately jumps down to number 25. Runs this line of code, hits this break, and watch where the yellow arrow goes next, all the way down to here. Okay? You can also do what's called a default statement. Like what happens right now if I type in the number 7? Nothing. But you can tell them that they picked an illegal starter with what's called the default case. What does he say? Are you a boy or a girl? The professor can never tell. He's very bad with identifying. Okay, so if I type in 7 now, no matter what number I type in, that will be what happens for the default. Okay?
And you don't need to put a break for default?
You could. It doesn't do anything
Okay.
because this is the last line here.
Okay.
What happens if I get rid of the break on each of these?
It'll run every single one.
It'll jump to the one that I picked and then continue to run every one after it. So I picked 2. See how it started off with Charmander? It says I picked Charmander, then Squirtle, then Pikachu, then some random ass starter. That's the weird part about switch statements is if you don't put a break in there, it'll run this line of code and then proceed to ignore the cases and just run every line of code afterwards. And sometimes it's actually useful for you. For now, just realize that that's what that does. Okay. All right, questions? So I'm just going to be honest. Switch statements, it takes a while to know how to write one of these from scratch without knowing the syntax. And most often than not, even if you never use switch statements, you'll be totally fine. Okay? You can use if and else if statements all day for the entire career. Be fine. There are some performance benefits to using switch statements. So it'll optimize things differently based on how many conditions you have. However, just keep in mind that for the most part, while we're in this class, you can use either interchangeably. All right? All right, questions? No questions? So switch statements in Overwatch, where do we use those? So I'm trying to think. Error codes sometimes. So like when we have we have switch statements for things like let's say you're inviting friends in Overwatch to play with you, right? We have certain cases that you're not allowed to invite friends into, and we have to tell you why you can't invite friends in the little chat that we have. Oftentimes, the way things work is in Overwatch, you'll write some code, say, hey, write this code to let this person invite another player. And when you do that, that code that you wrote will return back to you a number telling you whether it succeeded, or if it didn't succeed, a number corresponding to why it failed. It's just a number. It's a very simple number. The reason is memory constraints. And because it's a number, we will write like a switch statement that says, hey, this number, when you reach it, print this out to the chat. And the reason why that's commonly used that way is because a number is very simple to send over the wire. When you send it over the internet, it's a lot faster to send a tiny number than it is to send an entire error message. So we'll send you one number that works for the error code. And that's why a switch statement can sometimes be very helpful. All right. Phew. While loops are pretty simple, actually. This is what a while loop looks like. Now, I want to talk about what a loop does. You guys actually use loops in the Minecraft and the sketch examples in the first week of class. You had something that repeated behavior. Repeating behavior is a very important thing to do in code. Oftentimes, you want to do something more than once. So a while loop is the first of three that I'm going to show you guys of loops on how to use them in C++. The while loop is simple. You write the word while. You write an expression inside parentheses. Remember what an expression is. Just like an if, this is the same kind of expression you would put in an if statement. Okay? It's some condition that evaluates to true or false. If that is true, you'll run the statement, and then you go back to evaluate the expression again. As long as that expression continues to be true, you'll run the statement. Let me show you the simplest example of what this is. So I'm going to write a while loop that evaluates to true, and then I'm going to write a statement here. So it's going to run that expression. Say, hey, if this is true, run the statement. Then it's going to go back to the expression, and as long as that expression is true, it's going to print out that statement again.
I'm stuck in here.
So it's actually printing out right now.
It's continuing to print out forever.
So when will this stop?
Never.
Never. Because we never told it to stop. Okay? This is what's called an infinite loop. Okay? It's going to be on the midterm. This is a valid thing to do while true. You typically will write this for a game because you want the game to continue running, and oftentimes a game will loop like this. Imagine where it says, help me, I'm stuck in here. Instead of it saying that, imagine that it's rendering one frame of the game every time it says that. Think about like an animation. Imagine it's like showing you one frame of an animation and moving forward. This thing is now our very first and simplest game engine. Okay? It's an engine. Look, the program is just running. It's doing stuff on its own. I'm not touching it. It's running in the background. Although our game is very boring, it doesn't really do much, this represents the basic principle of surrounding a game loop. Every game loop has something like a while statement that loops forever. And now there are ways to break out of this. I will say, you can set up an infinite loop like this and still have the ability to exit. Otherwise, you would never be able to exit the games. You never be able to close the games. So there are ways to do this. One way, obviously, is I could just close this guy. And I'll close it. But I want to talk a little bit more about expressions, because this doesn't have to be true. What if I made something called a counter variable? And I'm just going to add 1 to it. And instead of printing this, I'm going to print the counter. You guys see what I did here? A variable. Add 1 to it and print it out. You guys see how it's adding 1 to it every time? I printed that out to the screen. Okay. I want to talk a little about this because watch, look where this variable is declared. This is going to be very, very, very important as to explaining why. Look where I put that variable. I put it before the while loop. Now I want to show you guys something. What happens if I put this variable inside the while? Now that variable is part of the statement that runs every time. It's stuck at 1, even though it was just adding 1 to it before. Why did it do that?
Because every time it goes back to the top, it just sets it back to 0.
Yeah.
That's 1 for sure. But also, this variable here, I'm just going to get rid of the equals 0 for now just to demonstrate that point. Where does this variable live?
Inside.
Look at the curly braces that it belongs to. Okay? Look at where this variable is in between these curly braces. Where that variable lives, it's what's called the scope of the variable. What is the scope of that counter variable? It's within this while loop, which means that that variable lives and dies inside the curly braces. What does that mean, it lives and dies? Well, it lives right here on line 11. It's a cute little variable. You guys ever watch Rick and Morty, Mr. Meeseeks?
Yeah.
Oh.
So like, it's like Mr. Meeseeks, all right? He appears right here on line 11. He does some stuff, and then when his job is done, he goes away. He's done. The while loop repeats, goes back to line 11, and makes a new variable called counter. Because that's what I told it to do. I declared it right there.
So it gets killed every time.
It gets killed every time through the loop, which is fine. It's totally fine with that, by the way. That's his whole purpose in life. It makes a variable. See how it makes a variable? Watch the yellow arrow here. Watch where it goes. Back up to number 9, and it's going to jump down to number 11 again. It's going to make that variable every time because the scope of this variable is within the curly braces. It lives within the curly braces. So the lifetime of a variable is from whenever it's declared until the end of the curly brace that it belongs to. Okay? That means also that I can only reference this variable within the curly braces. Watch what happens. For instance, I can't do this. I don't know if I said this to you guys, but you have to declare a variable first before you use it because it doesn't know what it is. So make sure that the order is correct. But if I were to put an if statement here, and I have another set of curly braces, and I put the variable in here, what is the scope of that variable now? On number 13. Here. It lives and dies inside here, which means it dies here. It means that this line of code doesn't even know about it. It's like another tiny little world where that variable lives. Now, it does work the other way. If I put this variable outside here, what is the scope of this variable counter? Within this curly brace here and the bottom curly brace down here, line 20. See, it's the entire program. It waits until the entire program, which means this variable lives and dies for the entire duration. It also means that I don't make it more than once. I make it one time, and the variable doesn't get recreated. So that's why I declare that variable outside of the curly braces. You have to keep this in mind whenever you're declaring variables. The lifetime of that variable and where you can use that variable is only within the scope of where that variable lives, only within where the curly braces contain it. Okay? Questions on that? There are some problems with this and some ways that you can use it to your advantage. For instance, I can do that. Typically, you can't do that. This is what's called variable shadowing. If I declare a variable with the same name twice, it's going to use that second variable. It's going to say, well, that's the one you wanted. That's the most recent one. It lives and dies within the while loop again. It doesn't get persisted outside of there. But you can also use this to your advantage. If you wanted to say, make a variable called counter inside of this, set it equal to 42, whatever you do inside of that doesn't matter. It doesn't affect anything outside of the curly braces here. It only affects what's inside this statement. So this, you can almost imagine this not affecting anything outside of this if statement. It's almost like it lives in its own world. You can almost imagine it doesn't even exist at all. This counter variable here is using the one declared on line 9. Why would you do this?
Yeah.
Oftentimes you can't think of a better variable name than counter. Or like you're writing some code that really you should only live and die within that if statement. Oftentimes when you're writing an if statement, something that's complicated, that's like 15 or 20 lines, you have to declare variables for that if statement. Now you could, let's just say for instance, like let's say we're calculating the average, right? Let's say we're doing the average, just like what we did earlier. Like so. I might want to use average later on down in the file, and I don't want other people that are working in the same file as me to worry about me naming these variables average, score 1, and score 2, and score 3. I only care about using these variables inside the if statement because they don't need to live outside of it. So oftentimes I'll make these variables, and I'll make them just within that scope of the if statement, just so that later on we don't run into that problem where we both declare something with the same name. I don't have to declare them here. I could declare them here. But now, a lot of my variables are all going in the same place. And typically you run into a problem where all of a sudden you start declaring a bunch of variables at the top here, and it gets kind of like complicated. Like there's a lot of these variables that are all being declared at the same spot. It's hard to read. And plus, you typically want the better programming standards, you declare your variables like this as close to the line of code that you're using them in. Okay? So like I'm going to calculate average. I'm going to declare that as much as possible. I'm going to declare that on the line right before I use it. That's the general standard. You want to kind of group variables together because the further apart your variables are from your code that uses it, the more likely it is that that variable will be used incorrectly between the start and end. Okay. All right. Let's move on. I have one more example based on this. So now I have my counter, right? And there's my true statement. I can set it up so my loop stops after 1,000 times by doing this. So that is my expression now. As long as counter is less than 1,000, go ahead and run that code. So this loop will run until that expression evaluates to false. Remember, that's how this thing works. So see how it stopped at 1,000 there? It's not running anymore. It ran 1,000 times because I'm adding 1 to it every time. And every time it goes through this loop, it's going to test to see if this expression is true or false. So watch. It's going to run that yellow arrow. It's going to go back up to here. It's going to see, is 1 less than 1,000? Is this number less than 1,000? It's true. So go ahead and run it one more time. Okay, so 2. And then 3. Is 3 less than 1,000? It is. So it keeps on doing this over and over and over again. Watch the yellow arrow. It's repeating over and over again. It's at 13 now, right? Mm-hmm. Continue to run. And as soon as the counter hits, so I'm at 504. I'm just going to change this counter to be 999. So counter is less than 1,000. It adds 1, prints out 1,000, goes up here. Is this going to be true or false now? 1,000 less than 1,000 is false. So watch where the yellow arrow goes now. It breaks out of the loop and goes to the end. Now this is pretty common. You use this for things like validating input or things like, hey, I want to do something let's say Farah has like a rocket barrage ability. Her rocket barrage ultimate ability means that she shoots out lots of rockets. That's just what she does. She spits out, gosh, I think it's like 20 or so rockets, maybe 15 rockets a second for like 4 seconds. That's a lot. So you basically write a loop to say how many times you want to do something like this. Like let's say I want to print it out, something onto the screen 1,000 times or 10,000 times. I just change this number here. And that'll make it print however many times that you want it to. Remove this breakpoint here. So now, this thing will run 10,000 times and then stop. Pretty common. Like, I want to spawn 5 skeletons in a room because I just entered a room in Diablo. Write a loop, make it spawn, do 5 of the same exact thing, spawn 5 skeletons, and then exit. Or I want to spawn loot in Diablo. I just killed a boss. Or in WoW. Or in Destiny. I spawn loot. I'm going to spawn 10 items. Or however many items the designer said that should spawn. Write a loop, do it 10 times, and then continue. Well, that's mostly because they didn't save off into memory, into a variable, what the condition of that room was, because it takes memory. Again, remember that everything that you want to save takes memory. And the older consoles didn't really have a lot of it to spare. So like in games like Mario, you couldn't go backwards. Like in games like Zelda, like the original Zelda, you'd leave a room and then come back to it and all the enemies would be there again because it couldn't remember what you had killed and what you had. Let's say you hit a guy once and then walked away and then came back. In order to remember that, you have to save off what the health of the enemy is for every single room in the entire world. There's no way that the Nintendo system back in the day had enough memory to save that. It had very little memory, actually. Nowadays, computers can store that. Like, you can kill someone in a room, come back, like, 2 years later, and that guy is still dead, right? Like in Skyrim, you guys ever, like, hoard, like, stuff in a room? Or, like, just, you have a house that you can store stuff in. It saves all the stuff you put inside that house, so you can come back later and saves all the positions of that. Sometimes, yeah. Okay. Any questions on loops? A lot of the homework is going to be based on this. Okay. Here's a variant on that. Same idea, but there's a new keyword called do in front of it. It works exactly the same way. However, the order is a little bit different. In a do while loop, it works like a while loop where there's an expression. However, the first thing it does, it runs the statement one time and then checks to see if it should do something. This is pretty common because in a lot of cases you might want to say, hey, enter your name, and then you want to check to see if that name is valid. Or hey, enter a number, and you want to see if they entered a number that's correct. So you want to make sure that you do something at least once, and if that number is incorrect, you want to keep asking them over and over again if it fails. For instance, let me show you how this works in a program. So this is our do while. The thing about do while is that you have to put a semicolon at the end of this while statement. I'm going to give you an option of, this is going to be a mock Pokemon battle. Okay. So look at this if statement, this while loop. It's going to run as long as this thing is equal to f. So watch what happens. The first thing that it asks is, do you want to fight or run? Make sure I didn't put any, space. I want to put E and DL here. So it will run this first. Without me even typing anything, the first thing it does is ask me if I want to fight. So I'll fight. And then ask me again, hey, Donald Trump appeared, do you want to fight? I keep fighting. And in this case, if I run, the program ends. So I could do something here, like this. So it'll repeat everything that's on lines 13 through 15 as long as I'm typing F. So I'll do this. And then I type R, and it says I escaped.
Or if you
Try
type
to
in the A,
escape, but he built the wall.
Yeah. So this is, yeah. I don't know. It's bad. Okay, so you guys get the idea, right? Like you enter a number or a letter, and it will repeat that.
I'll just say you try to escape, but you run into the
Okay. All right. So let's talk about break and continue statements. All right. There are two keywords you can do to control a loop. Remember I talked about infinite loops and how there are ways to exit out of infinite loops? So the break statement and the continue statement let you control what happens. Okay, so let me write a program here. My counter program here, again, while true, I'm just going to increment counter plus plus, and I'm going to see out like so. Remember what this program did? It just prints out infinite numbers like that. And remember, we said if counter is less than 1,000, while counter is less than 1,000, do this. Now, I can keep this in infinite loop, though, and watch what I can do. I can write an if statement, if counter is equal to 1,000, break. So as soon as that number hits 1,000, I use what's called a break. That does the same thing as if that expression evaluates to false. However, it immediately breaks. It immediately exits out of loop. So watch. I'm going to actually put this line of code here, right here. So if the counter is equal to 1,000, this expression is going to evaluate to true. It's going to run this line of code. And normally, it would also run this line of code here. However, break is very special. It says immediately bail out. It's like pulling an emergency window or emergency stop. It says don't run any more code in this while loop and immediately exit the statement. So watch what happens. It'll print 999 and then not print 1,000 and then exit. Because it skips over everything. It doesn't matter how much stuff you have written here. It will not run any of these lines of code once it hits 1,000. Okay. You can see it's actually running noticeably slower too now.
Yeah.
Does it have to do a lot more work? See, it doesn't print 1,000 at all. Okay. So that's the break statement. It lets you immediately exit out of the program. Now, we can also do what's called a continue. So continue is kind of similar to break. However, while break immediately exits you out of loop, continue immediately restarts the loop. I can say else if counter is less than 500, continue. Can anyone tell me what this will print out now because of this if statement here? What does continue do? It immediately restarts the loop. It'll actually skip printing out the first 500 numbers. It'll actually will not print out the first 500 numbers. I wish I could show you this from the beginning. let me do this.
Pause.
I'm going to do this. Okay. Here's my program. Watch my program here. See how it actually immediately stopped? Didn't even get to print out the first 500. Let's just do this to be 600 here. Watch the numbers that are printed out here. Started at 500 here. It skipped over the first 499 because I called continue. Now I'm actually going to put a breakpoint in and I'll show you how the execution works. Counter is 0 right now. I add 1 to it. It sees if this is true or not. This is false. It jumps to the else if. Is this true or false?
True.
Is 1 less than 500? Yes, it's true. So it goes into this, calls continue. Watch where this yellow arrow goes. It normally would go right here. However, it jumps all the way to the top. It restarts the loop. Okay? It will continue doing this, restarting the loop, until this number and see how it runs line 23 now. And now it's not continuing anymore. Okay? So break and continue allow you to restart or allow you to exit or restart the loop. Okay. Questions? Okay. Your homework's going to be 2 parts actually now. And I'm going to give you guys lab. I recommend you guys doing stuff in lab first and then working on the homework. So here's a couple of things. Let's go over the homework real quick. It's going to use all the stuff that you learned. And plus a little something from last week, too. Your homework is 2 problems. Only 2. The first one is actually not using if statements or loops or anything. I wanted to kind of give you guys another review because it was probably, I just don't think you guys can get enough of that. So it's actually using the modulus operator. So if you remember from last week, remember what the modulus operator does. It does a division and it returns you back what is left over. So for instance, 71 modulo 2 is equal to 11. So here's what I want you guys to do. I'm going to ask you guys ever have to do this, like measure height in inches and then convert into feet and inches? You're going to write a program that does that for you. So you're going to write a program that asks for your height in inches. So my height is 71. So you're going to convert that into a statement that prints out into feet and inches. Now here's the trick for this one. When you have a number like 71, your inches is going to be equal to this expression here. Your height modulus 12. 12 inches in a foot. That's going to give you back how many inches you're tall. Now, as far as how many feet tall you are, does anyone have any idea how you can calculate how many feet tall you are based on 71 inches?
Yeah,
Just divide by 12, right? So you're going to combine those two. You're going to take the division expression and the modulus expression, combine them to give you feet and inches. Okay? Second one. Okay, imagine you're playing Pokemon. You're an RPG character. You're playing as Pikachu or whatever. Unfortunately, this Pokemon that you're playing has been afflicted with a deadly virus. It's a poison dot and will eventually die. How sad. You forgot to buy antidotes, and our game is hard like Dark Souls. You just straight up just die if you get poisoned. So what I want you to do is ask for the health of this character. After you enter the health, you're going to write a while loop that subtracts 13 health from that character every time through the loop. Actually, I said 12. You can do 13. Depends on how harsh you are.
Your souls is 13.
You're going to print out the result of his health
It's a poison that somehow gives
every
you
loop. When that person eventually kills over and dies, you're going to print out that your hero has died. This is the very basics of an RPG game loop. Although typically you have some more interaction, you're not just dying to poison. Typically you're choosing things like whether you want to attack or whether you want to heal. But I want you guys to write a simple loop like this, where you enter health and you subtract health every time through the loop. You're going to be using either a do while or while loop. You can use either. They'll both work. It just depends on how you want to organize your code. You will use one or the other. Okay? And then you're going to print out when you're done. Questions on either of the questions here? Okay. Now, I'm going to put this up on Zool, but before you guys start on it, while you guys are here, if you feel so inclined and want to get a little bit more practice, I have a couple of practice labs using the stuff that we just talked about. Where is... Okay. So here's a few problems, and I put this up on Zool, so you guys can grab it. So we have... Let's see. There is... Yeah, this one is the good one. So pretty often in a game, you roll dice. Now, dice is like a physical definition of something that you toss and you get a random result. Oftentimes, dice are multiple-sided, 6-sided, 8-sided. In a game like an RPG, or something like League of Legends, or even like Pokemon, you roll like a 100-sided die, right? And then if that number is some value, let's imagine that this 100-sided die represents our critical hit chance. And if that number that we roll on the die is less than 10, or we can turn it around and say, if that number that you roll is greater than 90, you got a critical hit. So what I want to do is, I want you to write while you're here if you want to. And I'm going to end class, but I highly recommend you guys sticking around to do this. Ask for a number from the player from 0 to 99. Given that you have a 10% chance to crit, write an if statement that displays you got a critical hit if they got a critical hit, or you got a normal hit. So ask for a number from 0 to 99, and based on a number, so for instance, in my case, I'm going to treat any number that is greater than 90, greater than or equal to 90 as a critical hit. So I would write an if statement to say you got a critical hit if they typed in a 91, 92, or 93, all the way up to 99. Okay? That's this first one. Questions on that? You're basically just going to ask for a die roll. Then I'm going to ask you to write a switch, an Ifelse statement, kind of like what I just did with Pokemon. This time it's going to be picking heroes in Overwatch. Ask for a number from 0, between 0, really 0 to 4. You can say between the numbers 0, less than 5. But however many heroes you want to add. So I did 0 to 5. Have each number represent an Overwatch hero that they want to play as. This is an example of some of the heroes that you could show based on what they chose. Okay? So if they typed in 2, you'd say you could 4. I just did this in class, but I kind of want you guys to do it as well. And then I want you to convert that over to using a switch statement instead of using if, else, if. And then I want you to write, this is also part of the, you can do this for homework. This is basically what I just did. You know the counter example that I just wrote, where I created a variable for a counter and I counted up to 1,000? I want you to do that. I want you to have something that counts up to 1,000, but skip the numbers 1, 5, and 8. And actually, to make it easier, you don't even have to count to 1,000. Just make your thing count up to like 10. That way you don't have to like wait forever. So you're going to write 3 if statement that skips the numbers 1, 5, and 8. Okay? So these are just some practice problems that I'm going to give you, and I'll be here for the next half hour. So I highly recommend you guys sticking around and doing them. And this is up on Zool, so you can just open up the PowerPoint and do them. Okay? Otherwise, the homework is, I gave you guys homework. You get to head out, you're welcome to. And I'm going to upload this video right now. Thank you.